Introduction. Email remains a dominant communication tool, yet email spam presents significant cybersecurity risks and inefficiencies, with spam emails constituting over 45% of global email traffic. By pre-processing email text data, extracting features, and training the model with a label dataset, the system will classify emails as spam or non-spam, enhancing email management and security. Performance will be assessed using metrics such as accuracy, precision, recall, and F1 score, implemented with Python libraries like Pandas and scikit-learn. So, to address this, effective spam detection is essential. So, this project aims to develop an email spam detection system using the knife-based classifier, a machine learning algorithm for text classification. So, the system will classify emails as spam or non-spam, improving email management and user experience.
For the motivation part, spam emails are a major issue, making up over 45% of email traffic. These emails can spread malware, phishing scams, and other online threats, leading to serious concerns. The impact is widespread. Elderlies are particularly vulnerable due to their lack of technological knowledge, making them easier targets for these scams. Young adults, on the other hand, might fall for enticing scams promising quick money, putting their personal information and finances at risk. Organizations are not immune either. They face security risk, potential loss of sensitive information, and decreased productivity due to these email spams or email scam. Therefore, our project aims to tackle this issue by develop, developing an email spam detector by using the naive Bayes algorithm. This system will help classify and detect spam emails more effectively. The benefits are clear for individual users, cleaner inboxes, and reduced risk of malicious emails. For organizations, it enhances security, improves resource management, and boosts productivity.
For related work, spam detection is really important for keeping our emails safe and useful. Early research showed that computers could learn to spot spam pretty well. One method called knife bias turned out to be really good at this job. Over time, researchers made these methods even better. They found ways to look at how words in email are connected and how often they show up. This helped computers understand email more like humans do. Recently, people have tried using more complex computer programs that can understand the order of words and their meaning. But surprisingly, the simpler naive bias method is still really good at finding spam. In our project, we are using naive bias because it works well and it is fast. We are combining it with a way of processing words called TF-IDF, which help the computer understand which words are important. Spam detection keeps changing as new types of spam pop up, but by using both old and a new method together, we can still catch most of the spam and keep our inboxes clean.
Next, the implemented software is an email spam detection system using the naive Bayes classifier and TF-IDF vectorizations. It takes a dataset of labeled emails, spam and non-spam as input. First of all, data loading and pre-processing. The software loads the datasets from a specified file path and handles any parsing errors. It ensures that all text data is in string formats and handles missing values by filling them with empty strings. Then, data splitting. The dataset is split into the training and test sets using the train test split functions. The training set is used to train the naive Bayes classifier, while the test set is used to evaluate the performance of the training model. Next, Text data vectorizations. The text data is transformed into a numerical representations using TF-IDF vectorizations. This process converts the text into a format suitable for machine learning algorithms by assigning weights to each term based on its frequency and importance to the dataset. Stop words in the English language are excluded during vectorizations. Afterward, model training. The software trains a naive Bayes classifier, multinomial NB, on the training data using the fit method. This step involves the learning of patterns and correlations between the features and the corresponding labels, whether it's spam or non-spam. Last but not least, predictions and evaluations. The training model is used to predict the labels for the test data using the predict method. The accuracy of the predictions is calculated using the accuracy score functions, and a detailed classifications reports is generated using the classifications report functions. These metrics provide insights into the performance of models, including precision, recall, and F1 score for each class. Thank you.
For the email spam detection code. For the first step, importing the required libraries so that the code can run. The code imports necessary libraries like pandas, TF-IDF vectorizer, trend and split, multinomial NB, accuracy score, and classification report. Next, the code attempts to read the dataset using pd-read CSV. If a parser error occurs, it reads the file line by line and splits it by tabs, converts all data to string format, and handles missing values by filling them with empty strings. For the next step, the dataset is split into training and testing sets. Xtrain and Xtest contain the text data, while Ytrain and Ytest contain the labels. The text data is vectorized using TF-IDF vectorizer to convert it into a format suitable for machine learning. A naive Bayes classifier, multinomial NB, is trained on the training data. The model makes predictions on the test data, then the accuracy and a detailed classification report are printed, as the results shown. Next slide.
In conclusions, the implemented software is an email spam detection system using a naive Bayes classifier and TF-IDF vectorizations. It aims to accurately classify incoming emails as spam or not, addressing issues like reduced productivity, cybersecurity risks, and resource consumptions. The software's process includes data loading, preprocessing, splitting, vectorizations, model training, and evaluations. While this overview outlines the implementations, detailed performance metrics and comparisons with alternative approaches are needed to fully assess its effectiveness. By addressing the challenge associated with spam emails, we aim to enhance productivity, mitigate cybersecurity risks, and optimize resources utilizing in email management. Thank you.